Today we're diving into something one of you asked about, this idea of a law of constants as like a universal vibrational principle. And it's a great question because it touches on, well, everything from tiny particles right up to big philosophical ideas about the universe. What if everything you thought you knew about vibration was just, the tip of a much deeper, maybe weirder iceberg? So, our mission today is to untangle all these threads. We'll try to sort out the rigorous science from, say, coherent philosophy and maybe popular metaphysics. The goal is for you to end up with a much clearer, more differentiated, and hopefully empowering understanding of how things really work. So, yeah, let's unpack this. Okay, first off, that phrase, law of constants, especially when you link it to vibration, it doesn't really sound like standard science talk, does it? So, what is its most accurate scientific meaning, if there even is one?
You're spot on. That phrase, law of constants, in that context, it's not standard scientific lexicon at all. The closest thing, the most accurate parallel in science, is actually the first law of thermodynamics.
Oh, okay. Conservation of energy.
Exactly, the law of conservation of energy.
Yeah.
It's absolutely fundamental in physics and chemistry, too. It states that the total amount of energy and matter within a closed system, and we generally consider the universe a closed system for this, well, it stays constant over time. Energy can change form. Chemical energy can become heat, light can become heat, but you can't create it or destroy it. The total amount just stays the same.
Right. Like in chemistry, exothermic reactions release energy, endothermic absorb it, but the total energy of the system and surroundings doesn't change.
Precisely. It's a law about quantity, conservation, the unchanging sum total of what's available. But crucially, it says absolutely nothing about whether that energy is vibrational or oscillatory or anything like that. So connecting it directly to vibration, it's a fundamental categorical error. It's mixing up how much energy there is with how that energy moves or behaves.
Okay, that makes a lot of sense. It's about the amount, not the action. So if it's not standard scientific jargon for vibration, where else does this phrase, law of constants, actually show up? It must come from somewhere.
It does, and it's interesting how it pops up in really different places. That kind of highlights how ambiguous it is. It doesn't have a single clear definition like Newton's laws or something. For instance, in engineering, specifically in mineral processing, like crushing rocks.
Crushing rocks? Seriously?
Yeah, seriously. There's something called a drop weight crusher test, and it determines what engineers in that field call crushing law of constants. These are practical empirical parameters like Bond's work index that relate how much energy you need to break down rocks or minerals to a certain particle size. So it's physics in action, definitely, but it's entirely specific to material science and completely unrelated to some universal vibrational law.
Okay, wow. Crushing law of constants. That's unexpected. Where else?
Well, switching gears completely, you sometimes see it used as a literary metaphor.
As in, like, analyzing books.
Exactly. In cultural or literary criticism. I remember seeing an analysis of, I think it was Willie Cather's work, where the critic used law of constants metaphorically. They were describing a sort of zero-sum dynamic in how characters develop, suggesting there's this law of constants that governs the distribution of the reader's finite amount of sympathy.
Huh. That's purely figurative, then.
Totally figurative, just using the sound of the phrase.
From crushing rocks to reader sympathy. That's quite a range.
It really is. And maybe the most telling thing about how obscure or niche it is, it's even shown up as a wrong answer choice on an SAT subject test.
No way.
Yeah, in chemistry. It was put there specifically as a distractor, to catch students who weren't absolute precise about the first law of thermodynamics. It was basically a trick answer.
Okay, so the original query, the idea of a law of constants as a vibrational law, it seems like it's based on pulling a term from one context or maybe just a vaguely scientific-sounding phrase and applying it somewhere it doesn't belong.
That's a fair assessment, yes. A fundamental misattribution.
So if we want to talk seriously about a universal vibrational law, we need to ditch law of constants and look at the actual physics of waves and frequency. Now, the idea that something vibrates at one frequency and no other, well, it sounds neat and tidy, but I suspect reality is messier. How complex does vibration actually get in physics?
Oh, much messier and much more interesting. That one frequency idea describes an idealized, simple wave. Think of a pure sine wave on an oscilloscope, or that perfect hum from a theoretical tuning fork. That simple wave can be fully described by just a few things. Its frequency, how many cycles per second, measured in hertz, which determines pitch in sound or color in light. Then its amplitude, the maximum displacement, how big the wave is, relating to loudness or brightness, and its wavelength, the physical distance one wave cycle takes up. So yeah, a perfect theoretical tuning fork, one single defined frequency. But the real world, well, it's almost never that simple.
Okay, so ideal waves are simple. But what happens when these waves, meet each other in the real world? Do they just bounce off?
That's where it gets really cool. They don't bounce off like billiard balls. Waves pass through one another, and when they overlap in the same space, their displacements add up. This is called the principle of superposition.
Superposition, okay.
And this leads directly to wave interference. If two waves meet and their crests line up with crests and troughs with troughs, they reinforce each other. That's constructive interference. The amplitude gets bigger. Think of those surprising loud spots you sometimes find in a room with a stereo system. That's sound waves adding up.
Right, I've noticed that. And the opposite.
The opposite is destructive interference. That's when the crest of one wave lines up with the trough of another. They work against each other, decreasing the amplitude. If they're perfectly out of phase and have the same amplitude, they can actually cancel each other out completely.
Whoa. Is that how noise-canceling headphones work?
Exactly. They generate a sound wave that's precisely out of phase with the ambient noise hitting your ear. The two waves interfere destructively, and voila, much quieter.
That's amazing. So waves combining already makes things more complex than just one frequency.
Absolutely. It immediately creates complex, dynamic patterns that are composites of the original waves. The simple one-frequency model starts to break down right there.
But I feel like there's even more to it, right? Something about how complex sounds are built. You mentioned Fourier earlier.
Yes, Joseph Fourier. His work, Fourier's theorem, is incredibly profound here. What he showed is that any complex repeating waveform, no matter how jagged or intricate, can be mathematically broken down, decomposed into a sum of simple sine waves.
Any wave, like any sound.
Any periodic wave, yes. Think of it like a recipe. The complex wave has a main ingredient, the fundamental frequency. That's the lowest frequency in the mix, the one that determines the overall repetition rate, like the basic pitch of a musical note. But then you add other ingredients, harmonics, or sometimes called overtones. These are higher frequency sine waves whose frequencies are simple integer multiples of that fundamental frequency, twice the fundamental 2f, 3 times 3f, 4 times 4f, and so on.
So a musical note isn't just one frequency.
Almost never in the real world. The unique sound quality, the timbre of an instrument, why a piano sounds different from a violin playing the exact same note, say A4 at 440 hertz, is entirely down to the specific mix, the relative amplitudes of these different harmonics. Each instrument has its own harmonic recipe or fingerprint, and this isn't just for music. Even simple shapes like a square wave. That's actually a fundamental frequency plus only the odd-numbered harmonics, a sawtooth wave. That's the fundamental plus all the integer harmonics.
That's incredible. So the richness, the character of a sound comes from this complex blend of frequencies. It completely flips that one frequency and no other idea.
It absolutely does. The key takeaway from classical physics is that real-world vibration is defined by its complexity, its composition, not its purity. The statement, one frequency and no other, describes a theoretical ideal, a building block, but it's rarely the whole story in nature. The real law of vibration in the classical world is this interplay, superposition, and harmonic composition. It's inherently complex.
Okay, that's classical physics. But then things got even weirder with quantum mechanics, right? How does vibration look at that fundamental level?
Weirder and arguably even more fundamental. In quantum mechanics, that idea of superposition takes on a whole new meaning. It means a single quantum system, like one electron, can exist in a combination of multiple distinct states at the same time.
Multiple states, like multiple places at once.
Multiple places, yes, or different spin orientations or different energy levels. And crucially, these different quantum states often correspond to different frequencies associated with the particle's wave function. So mathematically, if state 1 and state 2 are possible states, then a combination like L-Slang-Racet is also a perfectly valid state. The system is literally in a probabilistic blend of both states simultaneously.
Until you look at it.
Exactly. This fuzzy probabilistic existence persists until a measurement is made. The act of measurement forces the system to choose, collapsing the wave function into just one definite state.
The Schrodinger's cat thing.
That's the most famous, albeit macroscopic, analogy. The cat is simultaneously alive and dead until the box is opened. For a particle, it might be simultaneously spinning up and down. This flatly contradicts the classical one frequency or one state idea. A single particle can be a blend of many possible frequencies or states at once. It's strange, but it's the foundation of things like quantum computing.
Mind-bending. Okay, let's go even deeper into the really theoretical stuff. String theory. How does vibration fit into that picture of the universe?
String theory is fascinating. It's one of the main contenders for a theory of everything, trying to unite quantum mechanics and general relativity. And its core proposal is that the most fundamental entities aren't point-like particles.
But strings.
Exactly. Tiny one-dimensional vibrating filaments of energy called strings, infinitesimally small. And in this model, vibration is identity. It's everything. The different ways these fundamental strings can vibrate, their different modes of oscillation, give rise to all the different particles we observe in the universe.
So an electron is just one way a string vibrates, and a photon is another way.
That's the idea. An
Yeah.
electron is one note. A photon is another note. Maybe the hypothetical graviton, or the particle carrying gravity is another. The entire universe, in this view, is like a vast cosmic symphony played on these tiny strings.
Wow. And didn't you mention extra dimensions?
Right. To make the math work, string theory typically requires more than the 3 spatial dimensions we experience. Original versions needed 10 total dimensions, 9 space, 1 time. M theory suggests 11. The idea is that these extra dimensions are compactified, curled up incredibly tightly, far too small for us to perceive directly.
Like looking at a thin wire from far away, it looks one-dimensional, but up close, it has thickness.
A good analogy. And the specific geometry, the shape of these curled up extra dimensions, is crucial. It actually constrains how the strings can vibrate. That geometry determines the possible vibrational modes and therefore determines the spectrum of particles that can exist and the values of the fundamental constants of nature. It's still highly theoretical, very hard to test experimentally, but it paints a picture where the universe literally is vibration at its most fundamental level.
Okay, so we've covered the science from thermodynamics misunderstanding, through classical waves and harmonics, to quantum weirdness and string theory symphonies. Fascinating stuff. But let's be honest, when people ask about a universal vibrational law and constants, they're often thinking of something, well, different, something more esoteric or metaphysical, right?
Very likely, yes.
Yeah.
That query often points towards a different lineage of thought altogether.
So where does that lineage really get articulated?
Probably the most explicit, well-known articulation of an esoteric law of vibration is in a book called The Kybalion. It was published in 1908 and claims to summarize ancient Hermetic philosophy, supposedly tracing back to Hermes Trismegistus. Its third core principle is the principle of vibration, and it states it very plainly. Nothing rests, everything moves, everything vibrates.
Okay, everything vibrates. How does the Kybalion explain that?
It presents a framework where all differences in the universe, from the densest matter right up to what it calls the all, or absolute spirit, are simply due to different rates or modes of vibration. It describes this vast spectrum. You have very slow, dense vibrations making up gross matter. Then the rate increases through things we perceive like sound, heat, light. Then it goes into subtler realms like ethereal substance and mental planes. And at the very highest end is the all, which it says vibrates so infinitely fast that it actually appears to be at rest, like a spinning top that looks stationary.
Interesting. And does it connect this to thoughts and feelings?
Yes, crucially. The principle extends fully into the mental realm. Every thought, every emotion, every mental state is said to possess its own corresponding vibration. And the main practical application discussed in Hermeticism, based on this, is something called mental transmutation. It's the idea of using your will, your focused mind, to consciously change your own mental states, essentially, raising or lowering your mental vibrations for self-mastery and inner development.
So the focus in the Kybalion version is internal, self-improvement, not necessarily changing the outside world.
Primarily, yes. It's more about internal alchemy, understanding the nature of reality and mastering one's own mind. It's less about, say, attracting a new car through vibration.
Okay, that's a key distinction, because that does sound different from the modern law of attraction. How did we get from that Hermetic idea to what's popular today?
That's where a really significant shift, almost a mutation, happened. The Hermetic law of vibration served as a philosophical seed, or maybe just inspiration, for the new thought movement that emerged in the 19th century.
You thought.
This movement started with figures like Phineas Quimby, who focused on mind cure, healing illness through thought. The power of the mind was central. Then, writers like Prentice Mulford, and especially William Walker Atkinson, who, interestingly, is also suspected by some to be one of the anonymous authors of The Kybalion, really popularized these ideas. Atkinson wrote a book in 1906 called Thought Vibration, or The Law of Attraction in the Thought World.
Ah, there it is. Law of attraction.
Exactly. And later figures like Napoleon Hill with Think and Grow Rich in 1937 cemented it. Here's the critical transformation. The Hermetic law of vibration was largely descriptive, this is how reality works, and focused internally, master your mind. New thought turned it into something prescriptive, do this to get results, and focused externally, change your reality. The core doctrine became that your thought vibrations don't just exist, they actively radiate outwards and attract back experiences, people, circumstances, even physical objects that have a similar vibrational frequency. The Hermetic everything vibrates became the necessary precondition for the new thought mantra, like attracts like. It wasn't just a map of reality anymore. It was presented as an engine you could use to change reality and acquire things.
So the focus really shifted from understanding yourself to manifesting external desires. Okay, within that modern law of attraction framework, how do they say this manifestation process actually works? What are the supposed mechanics?
In most modern law of attraction teachings, manifestation is usually explained as a process rooted in achieving vibrational alignment. The fundamental idea is that every thought you have, and especially every emotion you feel, carries a specific vibrational frequency.
High frequencies for good stuff, low for bad.
Generally, yes. High frequencies are associated with positive emotions. Love, joy, gratitude, feelings of abundance, peace. Low frequencies are linked to negative emotions. Fear, anger, jealousy, sadness, feelings of lack or victimhood. The core belief is that you are essentially a broadcasting tower, constantly sending out these vibrational signals based on your dominant thoughts and, more importantly, your feelings. The universe, or some universal intelligence or law, is said to respond by matching that frequency. It brings back to you experiences and circumstances that resonate with the signal you're emitting. So to attract wealth, for example, the idea is you must consistently vibrate at the frequency of abundance. And the real key, proponents emphasize, isn't just thinking positive thoughts, but actually feeling the emotion of already having what you desire. Embodying that feeling is seen as the most powerful vibrational signal you can send.
And practices like visualization and affirmations are meant to help cultivate that feeling.
Exactly. Creative visualization, repeating affirmations, keeping gratitude journals. These are all techniques aimed at generating and sustaining those high-frequency emotional states, that feeling of already having it. So the law of vibration in this context becomes the underlying engine. You attract what you are, vibrationally speaking. Your inner state supposedly dictates your outer reality.
It's definitely a compelling narrative for many people, but this is where we need to bring back the critical lens. How do these metaphysical claims stack up against scientific principles? You mentioned earlier the use of scientific language.
Right, and this is a crucial point for critical analysis. Modern law of attraction literature is absolutely saturated with scientific-sounding terms. Quantum, frequency, energy, vibration, resonance, atomic level, you name it. But the issue isn't just using science as a metaphor. It's often presented as if these concepts literally apply in the way science understands them, which is simply not the case. It's a misappropriation of terminology.
Can you give an example?
Sure. In physics, frequency has a precise measurable definition in hertz, cycles per second. In law of attraction, frequency becomes a vague, subjective metaphor for feelings or emotional states. Energy, in physics, is quantifiable, joules, electron volts, governed by laws like conservation. In law of attraction, energy often becomes a kind of mystical, undefined life force. And quantum physics is frequently invoked to justify macroscopic effects, like thoughts influencing distant events or objects, even though quantum phenomena, like superposition and entanglement, are generally understood to operate at the subatomic level and don't simply scale up to our everyday world in that manner. It functions really as a rhetorical strategy. Using these impressive-sounding words lends an air of scientific legitimacy and authority to claims that lack actual scientific backing.
Okay, so the language is borrowed, often inaccurately. What about the core claims themselves? When you put them under scrutiny, what does the actual evidence show?
Well, when you subject the core claims to scientific scrutiny, looking for empirical, testable evidence, they largely collapse. The belief system rests on premises that are demonstrably false from a physics perspective. Take the central idea, like attracts like, as a fundamental law. In physics, that's often untrue. In electromagnetism, it's opposite charges that attract, like charges repel. In gravity, all mass attracts all other mass, regardless of any likeness. There's no universal physical law of like attracts like.
What about thoughts as high-frequency waves?
Another major claim is that thoughts are energy waves vibrating at incredibly high frequencies, sometimes even compared to visible light, around 4 by 30 and 14 hertz or higher. But the actual electrical activity in the brain, measured by EEG, produces extremely low frequency waves, typically between 1 and 100 hertz. That's billions or trillions of times lower than light frequencies. There's simply no known biological mechanism for the brain to generate or transmit electromagnetic radiation anywhere near those claimed frequencies.
And the ether idea for thought transmission?
Right, some early writings mentioned thoughts traveling through an ether. That concept, the luminiferous ether, was a 19th century scientific theory proposed as a medium for light waves. But it was definitively disproven by the Michelson-Morley experiment back in 1887 and made completely obsolete by Einstein's theory of relativity over a century ago. It just doesn't exist.
So, if the proposed physical mechanisms don't hold up, how do we explain why some people feel it does work for them? There must be something going on.
Absolutely, there is something going on, but it's almost certainly psychological, not physical. Any perceived success of the law of attraction can be explained by well-established psychological principles. Firstly, cognitive reframing and positive thinking, focusing on positive outcomes, visualizing success. These techniques do change your emotional state. They can make you more optimistic, more confident, more proactive. This is used effectively in things like cognitive behavioral therapy, CBT. Law of attraction often mistakes this powerful psychological effect for a physical law influencing the universe.
Okay, so changing your mindset changes your behavior, which changes your results. Makes sense.
Exactly. Then there's confirmation bias. This is our inherent tendency to notice, interpret, and remember information that confirms what we already believe, while ignoring information that contradicts it. If you believe abundance is flowing to you, you'll notice every lucky break or found coin and conveniently forget all the times things didn't go your way.
We see what we expect to see.
Pretty much. There's also the placebo effect. We know that belief and expectation alone can create real, measurable, positive physiological or psychological changes. If you firmly believe a practice will make you feel better or succeed, it genuinely might, simply due to that belief. And finally, the self-fulfilling prophecy. Believing you will succeed often leads you to take actions, consciously or unconsciously, that actually make success more likely. You might try harder, persist longer, or project more confidence, all of which can improve your odds.
So, powerful psychological tools, but not a mystical law of the cosmos manipulating reality for you.
That's what the scientific evidence strongly suggests, yes.
This brings us to another critical point, which you touched on, the philosophical and ethical consequences of this belief system. Can you elaborate on that?
Yes, and this is perhaps the most serious critique for many people. By positing that individuals create their entire reality solely through their thoughts and vibrations, the law of attraction framework inevitably leads to implications of victim blaming. Well, if your thoughts attract all your experiences, the logical conclusion is that people experiencing terrible things, disease, poverty, accidents, violence, even being victims of natural disasters or systemic oppression like racism or sexism, must have somehow attracted those circumstances through their own negative vibrations or wrong thinking. This is a profoundly cruel conclusion for many, and it's empirically false. It completely ignores the massive roles played by genetics, biology, socioeconomic conditions, political systems, historical injustices, and just sheer random chance in people's lives. It can also discourage compassion. Some proponents explicitly advise avoiding people with negative vibrations, like those who are suffering, so as not to lower one's own frequency. Wallace Wattles, an early New Thought writer, even advised against charity for this reason.
Wow, that's harsh.
It can be. It can also foster what people sometimes call toxic positivity, the idea that one should always maintain a positive mindset and suppress or deny genuine negative emotions like grief, anger, or fear, because those emotions are seen as detrimental to manifestation. That's not psychologically healthy. And what happens when someone tries hard, visualizes, feels positive, but still doesn't achieve their desired outcome? The framework offers only one explanation. They didn't do it right. They didn't believe enough. Their vibration wasn't high enough. This can lead to intense feelings of guilt, shame, and self-blame, rather than acknowledging external factors or simple misfortune.
It puts all the onus and all the blame squarely on the individual's internal state.
Exactly. And finally, its intense focus on individual manifestation can sometimes discourage collective action and social responsibility. If the solution to all problems, even systemic ones like poverty or inequality, lies solely in individual thought change, it potentially diverts energy from political organizing, economic reform, or other collective efforts needed to address those larger issues.
Okay, what a comprehensive journey that was. We started with a simple query about a law of constants and vibration, and it really opened up this huge landscape. I think we definitely have a clearer picture now of how science, philosophy, and popular belief intersect and diverge on this topic.
Absolutely.
Yeah.
It might be helpful to quickly summarize the distinct concepts we've untangled here.
Hmm.
First, we had the law of conservation, what we call the scientific law of constants. That's the first law of thermodynamics. It's fundamental physics, about the total quantity of energy and matter being constant. Crucially, it's a law of quantity, not oscillation, and linking it to vibration in the way the query suggested is a categorical error.
Right.
Second, we explored the actual physics of vibration. This is the rigorous science of waves. We saw that real-world vibration isn't simple. It's complex, involving superposition and a rich blend of a fundamental frequency and multiple harmonics. That's Fourier's theorem. And at the quantum level, it gets even deeper with superposition of states. And in string theory, the universe itself might be vibration.
The symphony idea. Yeah.
Third, we looked at the Hermetic law of vibration, primarily from the Kabbalion. This is a philosophical framework using vibration as a model to understand different planes of reality, matter, mind, spirit. Its main application is mental transmutation for internal self-mastery. It's non-scientific, but it's a coherent philosophical system in its own right.
Focused inward.
Exactly. And fourth, we examine the new thought law of attraction. This is the more modern, popular belief system that evolved from new thought. It takes the Hermetic principle, but transforms it into an external law of attraction, claiming thought vibrations directly attract material realities. It often misappropriates scientific language, lacks supporting evidence, and as we discussed, carries some significant ethical concerns, particularly around victim blaming.
That's a really clear breakdown of the four different things often bundled together. So it seems the core intuition that vibration is somehow fundamental and profound in the universe, that intuition is actually correct, isn't it?
It really is.
From the way harmonics create the unique sound of a violin, to the weirdness of quantum fluctuations, maybe even to the theoretical music of vibrating strings defining particles, science reveals a cosmos that's absolutely alive with motion and oscillation. But it does so in ways that are far more intricate, complex, and ultimately, I think, more awe-inspiring than the simplified versions often found in popular metaphysics.
How's that?
The path to deeper understanding, it seems, doesn't lie in trying to boil everything down to one simplistic law, but in appreciating the different kinds of truths we can access through careful scientific inquiry, through understanding our own psychology, and through thoughtful ethical reflection. We really hope this deep dive has left you not just better informed, but maybe with a renewed sense of wonder about just how amazing and complex the universe really is. Keep digging, keep asking questions, keep exploring. We'll catch you on the next deep dive.